Thank you everybody for being here. I'm pleased that it's so crowded. Um, this talk is about usage of the cluster with our MapTyler software. We are a Swiss company, a small company, 10 people in this moment working with application of the open source tools and deployment of different open source workflows to large clients. We are experts on tiling. We do a lot of tiles all over the world for different people in different coordinate systems. One of the projects can you hear me in fact? One of the projects which we did is OpenMapTiles, which creates vector tiles for the whole world. We will speak about it on Friday at 10:30. And this is something what can help you to host the world maps on your own server. You just download about 50 gigabyte of pre-crunched vector tiles in a single package. So we prepare 126 million of PBFs and pack them in a single data package which you can download and put on your server, and then you get maps like this one with absolutely open way how you can use it. So you can use it for business, you can customize it, and for running a world map you need just a basic virtual machine with 8 gig of RAM and this 64 gig of SSD disk, and you're ready to go with raster tiles, vector tiles, or whatever you need for the whole world. But all the big players, they have satellite layers, right? So we have Google Maps, Mapbox, Bing, Microsoft, NASA, Blue Marble dataset. And I'm pleased to announce that we were working on OpenMapTiles satellite layer. So with the same approach, you can download a satellite layer and host it on your computer. This means about 200 gigabyte of data to host somewhere, but it's with similar approach to our vector tiles with OpenMapTiles. We have it now in the version 1 beta. And it looks like this when it's put on how to play it. So I need this. Like that, and yeah. When wrapped on terrain, you can go to any place on the Earth, and this is preview of the dataset. So anywhere on the Earth, you can see down to like 20 pixels per 20 meters per pixel resolution, cloudless. It's data made out of European satellites, Sentinel-2, so out of open data, in fact, which anybody can freely download. You can quite easily combine it with our vector tiles to get a hybrid map, and then it looks like that. So here everything what you see is hosted on a local, like self-hosted server. You can have the same thing on your own infrastructure if you need it, deploy it behind firewalls, offline, as you want. This is the resolution where you get. The OpenMapTiles satellite is available for preview now on this address, and if you send us your email, we can give you download links once we are out of beta, so the data are prepared. It's a result of work of Clocan Technologies, our team, and company from Austria who did the cloudless processing. We did the tiling, color correction, and other work to prepare it into the package which is compatible with tiles. For the rendering, we have used MapTyler. It's a commercial software which we have developed internally, and it's using GDAL. It's in fact competing with GDAL to Tiles, which is a utility I personally developed when I was a student for Google Summer of Code, I think 10 years ago. And it's since then we work on MapTyler so it's C++ implementation of the tiling and doing a lot of different, solving a lot of different issues which you hit if you create tiles, like date lines, different coordinate systems, different outputs. We support GeoPackage, WebP, optimizations of PNGs out of the box, and other stuff. So it's worth to have a look. On this talk, I wanted to show something practical. So this is the data set, the free or open data available. You can get to this resolution, but how you can get farther? In fact, with the open data in US, it's quite easy. You can just go to National Map and download the USGS raw open data, which are available as geodata, really. So with the location, SRS, coordinate systems, they are correctly placed. So just go to the interface. You select an area which you want to deploy or which you want to download, and choose either 1 foot imagery, 30 centimeters per pixel, or 1 meter, and it gives you a chance to select preview which files are available, and download the whole set, or just download for free all the raw data. If you download it, then it's pretty easy to launch our MapTyler, and this is how the user interface of MapTyler looks. If you use it as a desktop application, it's also available on the command line, and you can choose standard tiles and just drag and drop in the downloaded open data from the government. It will load all the geographic information included in the headers of the files, give you a preview of where each file is located, load the coordinate system, as I said, and you can adjust it further, choose what files are going to be processed, reorder them, and choose what you want to create, in fact. One of the outputs is a folder, and others are MapTiles, GeoPackage, and we have also a mobile app which you can get source code of and make it yours, in fact. And there is direct upload into cloud. There are a couple of advanced options for what you need to do for this particular data set is ignoring for a force band, because they encode infrared, I believe, into the force band, so it's not alpha channel, but it's infrared. There is a special option for that. You can adjust the zoom levels. Normally MapTyler suggests you everything automatically depending on what data you dropped in. Then you simply choose where to render. In this moment I made an MapTiles file, so it's all in one package. It's easier to transfer between servers and deploy with the software like Tile Server GDAL, Tile Server Mapnik, Tile Server PHP, or any other Node.js or another utilities which are just exposing the MapTiles. So this is like a flow now. Now it's crunching quite a lot of different files and turning these into tiles in a Mercator system. So real-time reprojection on demand. Also calculating the different zoom levels and reprojecting every single pixel. When it's rendered, you get different outputs. You can preview the map. So here we have what we have created out of the 32, I believe, input files, and there is upload to Amazon. So in fact, you don't need to install any server at all for hosting these data, because you can push it directly as tiles into Amazon S3 or Google Cloud Storage. And we give you WMTS, tile JSON, so you can open it in QGIS, ArcGIS directly from S3 or Google Cloud Storage without server at all. And there's the send to mobile app and merging. In fact, the utility allows to combine multiple sources. So if you have a single big image and then later on a new data comes, you want to overlap it. So before there were clouds, and now you want to put a clear data set over it. It's possible from here as well as on the remote sources. So if you have tiles on Amazon S3, you can in fact merge remotely, so it downloads the tiles which are partly transparent from the remote source and merge them, so you have updatable map stored directly on buckets. The whole thing which I showed here, it was with the user interface. Of course, for a very big task, you use command line. You don't use Mac or Windows. You probably use Linux. We have native packages, and the whole software is packed in a Docker, which is the easiest way how to deploy it. You can get it for free. It's a public Docker hub. A single command which you copy anywhere where is Linux, and run it, and it gives you GDAL with all the drivers, everything prepared. So it's pretty easy to deploy it on a cluster this way on any machine. Simply a Linux which supports Docker, bam, and you are ready to go. The whole software is of course documented, so all the options are available. And now for the whole world, we needed something more. So we reuse this utility which normally runs on a single computer and uses all the power, all the CPUs of the single computer on a cluster. And the approach is pretty basic. You can use similar approach for other tools as well. We split the task to the areas on the world. So each task is rendering certain part on the planet, and then we put these tasks into a task queue and launch as many workers as we want to speed up the rendering, and each worker is just getting pull from the queue what is he supposed to do, getting the input data from the bucket, and doing the crunching and pushing it to the output bucket. For the tiling on the world, we have used this approach, the input data. So this is a sample what we did. The data set you have seen, 4.5 terabyte of data, rendering on with the MapTyler Pro for about 20 days. It would be, if it would be single machine with 8 cores. If it would be GDAL 2 tiles, so the standard open source, it would be about a year. In fact, with this parallelization, we were done in about a day, 26 hours, with 18 machines, and quite small costs, or the costs are equal, because it doesn't matter if you run a single machine for a longer time or if you run multiple machines for a short time. And you can speed it up simply by bringing in more workers. So it's quite efficient. And in fact, we are working now with Google engineers to turn this approach into an application which you start directly on Google Cloud with one click. So there is a web interface for that, and it runs the way that you simply prepare all the input files into a bucket on Google Cloud, but it can be also on different cloud. You select which bucket should be processed, what kind of files. Then the master is going to scan the files which are stored on the bucket. So it's loading, not copying, just loading the information from the headers. So you know what geographical coverage is in individual files, if they are correct or not, at least according to the header. And then the web interface presents you with a preview of what you are going to render with the cluster. So for every file you can check what is the suggested zoom level, zoom resolution, and where it's stored. And then you choose where you want to render it, and either you create directly the tiles the same way like with MapTyler if it uploads to S3 directly, or you can create a package like GeoPackage out of the data. So here we were creating the bucket as an output where it should go. And the result, as I said, is either the tiles directly stored on S3 individually, every tile separately, or a single one package which you receive in the end, merged with everything together seamlessly. And then with a single click, the cluster is initialized. So now it's starting the seven workers which were suggested there. You can even see it in the Google Cloud console, where the instances are being launched and added just by the script. And in fact, you can speed up the cluster rendering by simply launching more workers. Then we have this fancy view on what is happening in the cluster. So now the 7 machines, each is like downloading the input data, which it is supposed to work on, and doing the processing. And we show the progress on this OpenLayers app, where the workers are reporting what each is doing. So you see how far they are with their geographic area which they are rendering, and then each is uploading the output into the final bucket. Of course, this is just a web interface. Behind we have the task queue, which I described. We have a logging system, so you can check if there is a problem. What was this problem? Go back to the command line and debug it. In fact, all the machines have SSH available, so you can check what processes are running. Here we see Cloud Push, which is our C++ low-level utility for uploading tiles locally in the cloud, able to do up to 4,000 tiles per second, so saturate 10 gigabit connection locally in the cloud like Amazon or Google. A utility which we tuned for about a week, just a single utility for uploading tiles into S3. Then voila, we are finished. So the individual parts are rendered, and now the utility itself stops the worker, so you don't pay for the machines because you don't need them anymore. The workers did their job. You can shut them down. And for the overview zoom levels, we are now downloading the individual parts and rendering the upper part of the pyramid, because the jobs were not able to crunch everything up to a single pixel up. If you do another approach, you will end up with glitches on the pixels, so it will not look good. This is the way to go, really. Then we are uploading the overviews, so the upper part of the map is done, and bam, now we have map hosted on Google Cloud Storage, rendered on a cluster, and this can be a map of the whole world down like to 30 centimeters, and you just need to launch more machines to render any amount of data you have available. In fact, inside of the bucket, we create a viewer, and those are the tiles stored in the bucket directly. You may be familiar with that. The viewer, which you see here, gives you just basic viewers in Leaflet, OpenLayers, so you have something to start with. If you don't want to code from scratch, you get directly viewered. It's the same what is available if you render maps with MapTyler Pro. The nice thing is WMTS, which is an open source project, able to turn any XYZ URL into WMTS compatible get capabilities document, so you can open any XYZ tiles hosted anywhere in ArcGIS, QGIS, and this is, as I said, open source. You can get it. It's part of tile server PHP, which we have developed. The TileJSON is nice thing, which allows us to bring this particular tile set into the global satellite map. So after the processing, we end up with Boston, which you can zoom in very deeply, because now it's triggering the data which we rendered during the session, and we are zooming to the place where we are, where you can count people walking on the street, really. So it's just, and the same way you can process any other raster data which are available. So we did this example on the open data available from the US government, but it can be local data, a stream from a satellite, or whatever you need. As I said, if you are interested in this, just drop us an email and we can do deployment of this rendering system on your infrastructure of choice. It can be deployed through Docker to any cloud. It can be a private cloud, VMware, whatever infrastructure you have, it's deployable that way. On the licensing, we don't restrict the use. So in fact, if you want to use this rendering component as part of your business and hide it behind your web interfaces or your software as a service, we are not against. It's in fact prepared and very often used like that by people you would not guess are using it. On the Cloud Launcher, this is something where we will deploy it in a next weeks. So in the end, you will go just to Google Cloud Platform, search for MapTyler, and you can launch the cluster rendering of data this way through the web interface. And we are committed to fix all the problems of data input which we don't know through the web interface. So you can use the cluster in a that easy way, really. So it's not anymore a desktop application, it's really a cluster application which is coordinating a number of workers and doing the job for you the way it should be in the future. As I said, deployment is possible anywhere. There are no restrictions on usage, and our team would be very glad to work with you and help you to use this in your systems. Thank you a lot. Those are the main links.
We've got some time for questions.
I'm curious how you, so you mentioned the tile JSON is used to re-render or to include your Boston layer in the global data set.
Mm-hmm.
Do you have to re-render that, or is that queried on the fly as you're looking at that?
The merging happens on the fly. I mean, the viewer which we shown is Mapbox GLJS, and it allows to load different sources, so you can combine different vector tiles, different raster tiles. And what we do is that we define a new source through style JSON, and you say where it should appear, and I can show it live maybe if I find where. You say on which zooms it should appear. And you can even work with the transparency during the zooming. So if the two raster layers are slightly there's a color difference. You can choose opacity, move it from one colors to another. So then for the end users, it's not visible at all. With our tile server GDAL server software, the same thing can happen on the server side. So you can generate raster tiles, which are hybrid tiles, so with the labels, and they can merge different tile JSON sources to produce a single tile in the end. Yeah. Yep.
Will you be supporting elevation data tile sets, for example, with the GeoPackage elevation extension?
We have elevation for the whole world available on the OpenMapTiles.com, so you can download it from us. It's raw, clean data down to 30 meters, and we generated contour lines and RGB tiles for Unity or another use cases, and yeah, it's out there. It's not part of the GeoPackage. Sorry. I don't know. I'm not familiar with the GeoPackage extension for elevation. So we encode the elevation into normal tiles as raster, the way that you can transfer it to the browser and you can make the terrain as you have seen. So the elevation is encoded into RGB channels, and you can decode it.
Any other questions? All right, let's give him a round of applause again.